Alright guys, today we are going to do applications of the fundamental theorem of algebra, and if you're wondering what that is, the fundamental theorem of algebra states that any polynomial of degree n has exactly n zeros, counting multiplicity. So for example, if I had the function in factored form x plus 1 squared times x plus 4 times x minus 3. If I wanted to find the degree of this function, we would have to consider this multiplicity of 2. Okay, so that means the power. So if I actually multiply this out, this would give me an x squared term. Here, this is to the first power, so this would have x. And this is to the first power, so this would be x. So if I add all of my exponents, that would give me x to the fourth. Now that's not the solution to that if I multiplied it. I'm only looking at the x's to find the degree. So this is a fourth degree. Therefore, based on the fundamental theorem of algebra, that means it's going to have 4 zeros. Or 4 solutions, 4 roots, okay? Alright, so it says if a complex number is a root of a polynomial, then its conjugate will also be a root. So complex roots always come in pairs. So if we had a plus bi, then you have to have a minus bi. An example of this would be 3 plus I, 3 minus I. So you just have to remember that those come in pairs, and I'll show you that as we're moving along. So I'll put some steps here for you on your notes to finding the solutions. So we're going to first of all find the real solutions of the polynomial from the graph, so we'll graph it. Then we're going to use synthetic division to divide out the real solutions, and then we'll use the quadratic formula or factor if possible to find your imaginary solutions. So let's go through this first example. So we're going to graph the first example, and I'm going to just do that here in Desmos. So we've got x to the 5th minus x to the 4th minus 3x to the 3rd plus 3x squared minus 4x plus 4. So here's our function graphed. So if you want to go back to step 1, it says find the real solutions. So the real solutions are where it crosses the x-axis. So I'm just going to click on all 3 real solutions. So I can see it has a real solution at x equals negative 2, at x equals 1, and at x equals 2. So let's just do it in steps. So we have x equals negative 2, x equals 1, and x equals 2. So that's step 1. Step 2 says then use synthetic division to divide out your real solutions. So because you have 3 real solutions, we're going to do synthetic 3 different times. Because let's go back, I should have already said this. There's 5 total solutions. Based off of the graph, we can only see 3 of those. There's 3 real, so that tells me there's 2 imaginary roots, okay? Alright, so I'm going to take the first one, negative 2, I'm going to put it in the box, just like you learned yesterday with synthetic division. And then make sure you don't need a placeholder, so you've got x to the 5th, 4th, 3rd, squared, first, constant. So we're good, so take all your coefficients. And we're going to do synthetic. So first one comes down, multiply, always adding down. So I get the 0 remainder. And we're good there. You should get a 0 remainder, but you're not finished. So you're going to take your next real root, and the answers that you got from your first time with synthetic is actually the row that you use for the second go around. Because remember, it says you're going to use quadratic formula. You can't use quadratic formula until you have a quadratic. So if I wrote my solution right here, because this is x to the fifth, this would say x to the fourth. I've got to keep doing synthetic until I get an x squared. So this 1's going to come straight down. We're multiplying. And you see I get a 0 remainder again. So then we're going to do it one more time with that last real root. 1 comes down, multiply. So now I can write my quadratic. So I have x squared plus 0x plus 1. So here's the quadratic that you want to form to be able to do step 3. Okay, so I'm going to come over here with step 3. And we know we're not going to write that as 0x, so we really have x squared plus 1. And I'm going to set that equal to 0 to be able to solve it to find the roots. So you could do quadratic formula here, but a little bit easier when it's just two terms like this. Let's just go ahead and subtract that 1 over. So we would get x squared equals negative 1. So then when I take the square root of both sides, anytime we take the square root, you should get two solutions, plus and a minus. You know the negative comes out as I, so you basically have plus or minus I for your two imaginary roots. So your solutions for this problem are x equals negative 2, x equals 1, x equals 2, x equals positive I, and x equals negative I. We said we needed 5. There's all 5 solutions. Okay, so let's try another one. Example 2. It asks you to find the zeros for this quartic function. So if you look, there are 4 total solutions. 4 zeros. So I've already graphed this in Desmos for us, because remember the first step, we're going to find the real zeros. So if we click here, real zeros are where it crosses the x-axis. I can see that I have one at x equals negative 3 and x equals positive 3. Step 2 is to do synthetic division with those two real roots. Make sure you do not need a placeholder. So we have x to the 4th, 3rd, squared, 1st, constant. So you're good there. So we're going to put negative 3 in the box first. So coefficients are 1, 1, negative 7, negative 9, negative 18. 1 comes straight down, multiply, always adding down. And again, we should get 0 as a remainder. You're going to use that as the row for your second synthetic with the second real root. First number always comes down, multiply. And you should get a remainder again. So if you started with x to the 4th, this row would have been x to the 3rd. So that means this is x squared. So we have 1x squared plus 1x plus 2 for our quadratic. I'm going to go ahead and set that equal to 0. So step 3, I'm going to try to do AC. If I can, that's great. If you look, we would be looking for factors of 2 that would give us 1, and we can't do that. So you're going to have to do quadratic formula. And just to refresh your mind, opposite of b plus or minus the square root, b squared minus 4ac, all that over 2a. So in this case, our a is 1, our b is 1, and our c is 2. So I'm going to pop those into the formula. So x equals opposite of b plus or minus the square root of b squared minus 4 times a times c, all that over 2 times a. And then you want to simplify. So this is going to be 1 minus 8, so we're going to have negative 7 under the radical. And then remember, the negative comes out as I. So we're going to have x equals negative 1 plus or minus I square root of 7, all that over 2. So your 4 solutions are going to be x equals negative 3, x equals positive 3, and then this plus or minus gives us our other 2 solutions here. I've got a your turn for you to try. I'm going to give you the answer to that so you can try it on your own. So you've got x equals negative 1, x equals 2, and then x equals 1 plus or minus I square root of 23 over 4. So give this one a try, pause the video, see if you can get that, and then we're going to move on.